All right, awesome. Well, why don't we get started here? Kit is traveling for a little bit of vacation this week, so we're carrying on without him. But I'm very glad to be joined by Daniel here, who's been doing some incredible work on getting ZIO Flow from being kind of very early stage to being something where we've actually got a release candidate for. So I thought this would be a cool time to talk a little bit about what this library is and demo it for everyone. And then I think it's one where we're very actively looking for feedback. So I think both of you have feedback as you're looking at this. We'd love to hear that, as well as hopefully some people want to kind of try this out in some more real world use cases and help us kind of take this next level. But with that, maybe Daniel, do you want to introduce a little bit about what this library is and what problem it's trying to solve?
Yes, sure. So ZIO Flow is a workflow engine, or a library and a server for specifying and running workflows in a persistent way. So you should imagine it like you can specify a workflow that somehow performs actions with the external world. Maybe it's a long-running workflow. It can run for, I don't know, days or months even. And you submit this to a workflow executor, and you don't have to care about how is it executed, how it deals with errors, what happens if the server needs to be restarted, and so on. So it's a persistent execution of potentially longer running workflows. And it's having a very similar syntax to writing a ZIO program. So everybody who is familiar with ZIO can, I think, feel familiar with writing a ZIO Flow program. I hope it when we demonstrate it a little bit later, you will find it the same. Yes, and this first version consists of the library for specifying these workflows. It also has a persistent executor, which can run on a single node, but it can connect to different kind of databases and persists all the state of all the workflows and supports resuming them in case it got restarted. It currently supports DynamoDB, Cassandra, and RocksDB as a backend, and it also comes with so you can use this engine as an embedded thing in your own application, but you can also use the server version that we wrote, which is basically an executable version of this executor that you just have to write the configuration for and then start it, and it connects everything and provides a REST API for submitting these workflows and querying their status. And there are a lot of details of what kind of features it supports, but this is the short version, I would say. And I think probably the best way to continue is to just start writing some code and show it. So
yeah.
Yeah,
you want to share your screen?
Yes, I will try.
Okay, perfect. There we go.
I think it worked.
Yeah, I'm seeing the screen.
So I just have to move this Zoom toolbar somehow from here. Okay. So what I wanted to show first, just that we also wrote first version of the documentation page. So if you go to
amazing
ZIO dev/ZIO Flow, ZFlow, whatever. So it's in the official ZIO documentation site, and you find a lot of examples of how to define workflows, how to do some detailed stuff that I will show. How to write activities, which is the way how you communicate with the external world, how you can execute this stuff, and how you can use this server version that I mentioned, what kind of database connections we have, and how you can test your workflows. And there are no examples yet. There are some in this GitHub link here, but yeah, this page definitely needs some more work. And yeah, and there are even some internal documentation about how things works under the hood. So I just wanted to show that some kind of documentation already exists. So hopefully it helps getting started. And if we want to get started, we just have to use latest ZIO version. And the latest published ZIO Flow version is 1.0 RC1. And this ZIO Flow artifact is the main entry point for the library. This is what you need to define workflows. And if you also want to execute them, then you need the ZIO Flow runtime artifact. And the idea is that there will be a library of connections to third-party services, basically. And one example to that is that video activity library for ZIO Flow that I will use in the demo. So I also included that one. Yeah, so we can just start. I don't know, should I switch to a larger font maybe?
Yeah, that's probably a good idea. I can see
Yeah.
it okay, but I have,
Okay.
yeah.
So, so we can just write our first ZIO Flow program, which can be something like, let's use a for comprehension just to make it easier to extend it later. But the simplest program that I can think of is something that, let's say, logs a message. Yeah, so that's it. And we can make it a ZIO up default, so we can run it eventually. Yeah, so what now? This has the type ZFlow, any nothing unit. It is type parameters are basically very similar to the ones of ZIO itself. So it means that it doesn't have any required input. It's not failing, and its result is a unit. But of course, ZFlow is not a ZIO program, so we cannot just run it like this. There is something called ZFlow executor, and it has a run method, which requires a flow ID and the flow to be executed. So the flow ID is really just an ID, so it will be demo in this example. And we just say we want to run flow 1. So it's almost good. If you try to compile this, we will see that the zoom toolbar is here again. Okay, yeah, that we don't have an implicit schema for Z nothing. So we just, when working with ZIO Flow, we want to import everything from the ZIO Flow package because it's heavily building on some implicits. So unfortunately, to make it work, you usually have to import everything. So now, if we try to compile it, it says that we need a ZFlow executor. So let's provide it. There is one that is, there is only one really, which is called persistent executor. So this looks good. And as you can see, it requires a lot of things. So it requires a key value store for persistence. It requires some other executors and environments and whatever. So it's not really friendly. But there are some predefined layers. One is ZFlow executor default in-memory JSON. So let's see if it's better. Yeah, so it only requires now a configuration. I will show what configuration is, but we can use configuration in memory for this demo. And that's it. And we can run our first ZFlow program. And it logged some stuff. It's looking for the persistent state for the flow demo. There is no persistent state because it's the first time we are running it and it's in memory anyway. And then it logs the message. So first program worked.
Yeah.
Yeah, so let's do something just slightly more difficult. We want to have a parameter for this flow because if you are thinking of a real world use case, you probably don't want to, I mean, you probably want to write flows once and then provide some parameters for them when you are running them. I will show more examples of that, but the way how ZFlow works is that you can require an input, and let's say we are requiring an input of string. And we just want to do the same thing, but logging the input parameter now. So you would try to write something like this. And unfortunately, this compiles. Yeah, so if we do this, then it will not compile because now we require a string in the R parameter as an input, and we don't have a way to provide it, so we have to just provide it, you know, like this, for example. And now we can run this again. And that's not what we want. It prints some stupid thing with the UUID and some other constructor names. And that's the reason is that what I wanted to show you, that in a ZFlow program, every value is actually having the type remote of something. So if we get the parameter, it's a remote of string. And this unbound, whatever, is just an instance of the remote type. So if you are just using this string interpolator here, then it's not able to extract the value for you. A very large part of ZIO Flow is about how you can work with these remote values instead of the normal Scala values. And the whole purpose of this is that everything has to be serializable. So as I will show you a little bit later, these ZFlow values can be very simply saved to a JSON, for example, and sent over the wire for execution. And if you are working with regular Scala types, it's not always possible. So for example, if you just imagine that you have a, let's say, what we can do with a string, we can, I don't know, call to a parent in each character. Now we have a function here, and you cannot really serialize this function. But with using remotes, it's possible. So this ZFlow is a completely valid flow that you can serialize to JSON. And the way how we fix the string interpolation is that we have to use the string interpolator that is designed for working with remotes, which is just RS. And if we run this, then hopefully it will do what we want. No, and it's not, because this is some kind of for comprehension related. Oh yeah, sorry. Yeah, because the remotes are no.
We have a difference. So we have a remote in one part of the for comprehension, we have flow in the other part.
Okay. I don't know. Oh yeah, so it's thinking now that it's a list. I don't know. Let's do it another way. So let's just first show the first example that it works. And where is the run button here? Yeah, so this one works.
There we go. Yay.
Now, if we write something like this, then this should be, yeah, it's a map function in remote string, which requires a function from remote character to remote character and provides a remote string. So this should also work. And yeah, it does. So sometimes when mixing calculations with remotes and ZFlows, then for comprehension is sometimes not finding the proper way to flat map all these things together. And the reason is that remotes values are implicitly convertible to ZFlows or something related to that. So normally, if you want to work with remotes, like writing a more complicated function, it's better to create functions that are ZFlow functions, and then it always works when you are composing them. Yeah, I'm not completely sure why was the error there. Okay, so let's do something else. There is something that I didn't talk about yet. ZIO Flow supports transactions, which are capable of many things, but one thing that they can do is that you can define persistent variables that are accessible from multiple running sub workflows, let's say, which are similar to fibers in ZIO. And if you are accessing these variables from these fibers, like the fiber-like constructs, then it acts similar to using STM from ZIO fibers. So if you are modifying the same thing from two parallel transactions, then when you are committing the transaction, then consistency will be checked and enforced. And if there is a collision of the values, then one of the transactions will be restarted and so on. But it's also capable of just retrying a transactional block until a condition is met, and I will show that one. So let's say we once again require an input of string. But now we are, instead of using it immediately, we are creating a such persistent variable that I was talking about, like ZFlow new var. And you have to provide a name, which is just basically for debugging purposes, and an initial value. And for this, so what I want to write now is we have a variable, but it doesn't have the name at first, and we launch a fiber that waits until the name is provided and then does something. So let's start with a none value. You could maybe write none here, but no, because the none has the type option nothing, and then it cannot figure out the type of the remote value. So there are some helpers on remote for these kind of cases, like remote.none creates a remote option A, like this. So yeah, there are some differences when working with remote types from regular Scala types, but I try to minimize them. So now we have this variable, which is just a reference to something persistent. And it stores the value of none, but it's not really, I mean, it's just a variable reference. And now we create a fiber. First, we create a transaction. And within this transaction, we do a before comprehension, and we first try to get the value from this remote, or this persistent variable, like this. No, like this. Yeah, so this is once again a remote option string. You fetch the value from the persistent store, and at this point this would be none. So we can say retry this transaction until some predicate is true, becomes true. So we can say current name is defined. And then we can say, let's do now ZFlow log. Just what we were playing with before. And now, after, yeah, we define this transaction and we call fork to start it as a sub workflow, basically. And yeah, so now if we run this, now we first have to change this to flow 3. And now if we run this, we will not, it's not, oh yes, sorry, it's an option string. This remote string interpolator is a little bit more limited than the regular one. You always have to use strings in it. So we have to, now, so because of this line, we can be sure that current name is always a sum and not a none of string. So we can just call the get, but we could write get or else or whatever to even be more safe. But let's just do this. Okay. So now, yeah, so I just wanted to show that it does things, but it's not logging anything because we never never even wait for the fiber. So let's do first that.
Right.
Which is similar to doing it with ZIO. Yeah, of course, if we do something here, like this, then it also works like you would expect. So now this is a flow of either the nothing or integer, because the fiber, the await is returning an either, because the fiber could fail. And we can just, log this out. And now if we do this, it will not complete ever, because this fiber is waiting for the current name to be defined forever. Yeah, so let's say that before we start waiting for this, we will set name var to name, to some name. And we can do this. Well, the simplest way is just to sleep a little bit. I will probably show some other scheduling options later, but let's say sleep for 2 seconds. And now let's try it again. Yes, it's not doing anything, and then it printed it. So yeah, what we see here actually is that this whole body of the transaction gets suspended at this place because the condition is not true, and it is not. So I can actually show that if we log here something.
Right, it's not doing a busy loop.
Yes, that's what I'm trying. That's what I'm hoping. Yeah, so transaction is running once, and then after 2 seconds, it's running again because ZIO Flow notified this fiber that the underlying persistent variable called name has changed, and then it restarts and tries it again. And if now the condition is true, then it continues running and eventually finishes. And you can also see that the result gets out of the flow and gets to the ZIO level out here. So yeah, and with this transaction blocks, you can do much more. So as I said, if you are changing, like using this set or update method on persistent variables in transactions that are running in parallel because you forked multiple one of them, then they guarantee the consistency, as I said. And also, if you are calling any kind of external service in the way that I will present soon. So let's say you created, I called a third-party service here. That is also part of the transaction. So if you have to revert for some reason, like because this retry until restarts the whole thing, or because here was a failure or whatever, the transaction gets rolled back, then there are ways to define that such a third-party service call, how to roll back that, and it will do it for you automatically. And also when it got restarted, there is also ways to define how to verify that this call was already made once. And if you have a way to do that, then it will not call it again when this transaction restarts. And yeah, but first let's do something more simple. Yeah, as I said, there are some libraries that are supposed to provide connections to third-party services, and one of them is for sending messages through Twilio. It's just it only has one activity, I believe. And if we go here, yes, called send SMS. So let's try to use that. So it's an activity that has two type parameters: create message and message. One is the input, the other is the output. Each activity has an input and an output, and they are really like function calls. So you can just, okay, this is not really helpful, but you can you just have to provide a create message value here, which is just a case class representing the Twilio's send or create message API. It's the same fields and so on. So let's say, I think it needs a from and a to. And I think it also needs a body, yes. And that should be it. Let's try to run it. Okay, so it's failed. And why did it fail? Could not find configuration for authentication Twilio account service ID or whatever this is. So yeah, there is one feature that I didn't talk about yet, that you can provide or inject configuration values into your workflows. And the way this send SMS is defined is that it requires, actually, where is that? It requires a configuration value for Twilio account seed and also one for Twilio out token. These are basically configuration keys. And I showed in the beginning that we provided an in-memory configuration. This is the repository for these configuration values. And there is some more useful versions. There is one from config, which loads them from the new config provider of ZIO core. And also another, which is getting these values from environment variables. You just have to provide a mapping from environment variable name to config key. But if you are using the in-memory one, you can also do this by, let's move this like this, and configuration set. Set it to something. And it's, oh, sorry. Yeah, like that. And now it will complain about the other configuration value, which is called out token. And if we do that, I hope that these are not valid account IDs and tokens. Yeah, so now it really did the post request to the Twilio API. And this logging is a little bit weird with all these slashes, but it failed because Twilio itself returned with this error code and message that authentication error, invalid username, and so on. So yeah, so these activities are how you can communicate with the outside world. And in this first release candidate, we only provide built-in support for communicating through HTTP APIs. That's the only kind of activity that you can define. But it's not completely true, because you can define your custom operations. Operation is one part of the activity. I will show it immediately. So you can define your own, but then you have to provide an executor for that. So that only works when you are using the executor in an embedded mode like we are doing now. And so here, if we are just looking at what this default in-memory JSON layer is constructing, somehow it has a default operation executor layer. And this is the thing that you have to replace if you want custom operations to be supported. And there was a bug related to that, so it's not working on RC1, but it's already fixed on the main branch. Okay, so I don't want to deal with Twilio APIs at the moment in this live demonstration. So let's create something easier. Let's continue the very useful Hello World example, but now through a remote service, like custom service. Okay, and so this has to be an activity. Like I said, this is an activity. So we need to somehow specify an activity. And we do that by just creating a value which has the type activity with an input and the result. The input here, okay, this is yeah, let's say that we just provide the name part, and we will do the concatenation of the strings in the server side, let's say.
The server's doing some complex logic.
Yes. Yeah, just so, and then we get back it as a string. So this is a string concatenation service. Yeah, so the parameters are, why is it not show? Oh, because this is a type declaration, sorry. Parameters are a name for this, a description. And this part is that I already mentioned the operation, and this is the actual thing to do when you are running this activity. And we have one such operation, which is called HTTP. So if you do that, you have to provide a host. And an API definition. And here we have a nice DSL, which I think works better if we import everything, probably. Yeah, so it starts with a with a method name and the path. So let's say test, and here we can inject parameters. I think it's based on Kit's ZIO HTTP DSL whatever library actually originally. Yeah, oh sorry, this is the one that we have to import. So this adds one string to the input of the activity, and we can do like say that we don't have an input body is a unit, and the respawn or output is a string, and I think that's it what we need. But it also allows you to specify query parameters and so on, and everything that is like a placeholder that you include here, like we can just write one more string here. It will modify the type of this operation, and yeah, I will show it once all the parameters are filled. So the last two parameters to give here is check and compensate. Check is check is a Z flow, which if you provide, then it will be executed when this activity is called from a transaction and has to be repeated. This check flow can decide to just return the value without actually calling the operation. So if this check flow fails, then the activity will be performed. If it's returning with a string, that string is used as a placeholder for the already executed activity. So this way you can prevent from calling something twice. Or if and this is a Z flow, so you can do any number of steps in it. So you can, for example, query or remote API whether the actual entity is already existing or I don't know, a payment has been started or not, and such things. And the second parameter is compensate. That is what this is also a Z flow, and it's executed when you are rolling back a transaction which already executed this activity. But now we won't use this, so you can just say activity check not supported, and compensate is not supported either. So now this has the type string, but as I said, if we add any other input, like let's say we want to send a number as the body of the request, then it will be an HTTP. The operation itself will have an input which is a pair of string and integer, and it's no longer compiling. And if we similarly, if we add an integer here, that it's also added, and so on. So yeah, and the output can be a unit, and then we don't have any output. And all these DSL elements are basically constructing your input and output types. So now that we have this custom service, we can probably just execute this flow. And let's print it in different ways, and let's see what happens. Yeah. Oh, I was too fast. I didn't want it to work, but I yeah. So let's stop this custom service that I already started before the.
I was wondering. I was like, hold on, we haven't
I was
implemented this
surprised.
actual
Yeah.
backend.
I wanted to show that it's doing a request to localhost and it's failed because of connection refused. And I wanted to show that we can write a very simple ZIO HTTP service, which is just asking for reacting to a post request, which starts with a test and then gets a string. And it does this very complicated algorithm to concatenate the hello and the string. And and that's the whole service actually. And and one detail here is that we have to return a JSON string because in ZIO Flow, by default at least, it always encodes and decodes the request body and response body as JSON. So this is a JSON string that we are returning here. And if we start this again, and then we are running this again, and it works.
Nice.
So okay. So what else I wanted to show? Yeah, I wanted to just, maybe I already said it several times, but I wanted to show that the working with the remotes is designed to be very similar to working with the non-remote values. And just one more example, which is remote oriented, let's say. Let's say we ask for an input of string. This is probably already boring, but I cannot figure out anything else. And let's say we calculate something like let's take this input, which is a string. We can not like that input. Let's split it by spaces and commas and dots, let's say. And then we have a list of strings, so we can map it to, let's say, the string length to the string. I'm wondering if this is a syntax sugar that works or not. We will see. Probably it works. And then we have a remote list of tuples of an integer and the string, and then we can group by the length, for example. So we can use all these usual standard Scala library functions, but these are not the real standard library functions. Let's see if this works. Flow 6. Okay. No, I don't know what is it doing. Yeah, so this is again the same problem that I didn't understand for the first time either. Okay, let's say we have a string. Input. So this is a function on remote, and it returns a remote map of int to list of intent string. And if we just do it like this, I think it will compile. Yes, it's something with the mixing of remotes and Z flows enough for comprehension, but I'm not sure exactly. Oh, I'm running this service again. Sorry. Yeah. So yeah, it returned with this complicated map which contains the word count map. So for example, length 5 has 2 elements and so on. Yeah, so I just wanted to demonstrate that this is a remote function to a function from a remote value to a remote value, represented by a real Scala function, but the whole thing is serializable. And if we just go into the definition of these things, let's say group by, you will see that this is not the standard Scala library. It's all built on top of the remote data type, which actually has some nice features, for example. And yeah, some nice features and some features that are there because you have to have them. So for example, you cannot have you cannot just create I cannot edit this, but you cannot create local variables because those will be just placeholders or remote descriptions of computations. So it's not helping at all. So we can use this bind instead to calculate something only once and then be able to use it in multiple places. So like this key is used in 2 places and only calculated once. You can also write things like this. And that will help you with more complicated remote functions to see what's going on. So now if we run this, it will. It's not okay. It's a debug. It's printing this in debug log level. So yeah, we need to change the log level, which is actually I think it's still very hard in ZIO latest ZIO version, but
You can add a new logger.
yeah, but that's a little bit complicated in my opinion.
I know,
it's like
yeah.
I don't is it runtime? Not that runtime, but yeah, I just noticed that logger, vlogger, default map.
Yeah, that map print line, yeah.
Yeah, so yeah, I think if we run this, it will print everything or some of the things twice, but I'm running the wrong thing. But yeah, so now it's logging a lot of things.
A lot of stuff.
But it's also should like split. Yeah, it's printing every time one of these remotes are calculated that are tagged with a debug. It's added to the log, which is very useful for debugging this stuff. But let's remove this debug line from here or debug logger from here. And the next thing I wanted to show, if we still have time,
definitely,
is that was some basic examples how you define workflows, and hopefully you can imagine that this can be actually used for something useful as well. And you can embed all these layers in your application, and you can choose a key value store, which is not the in-memory, and index store, which is not in-memory. As I said, there is a DynamoDB, a RocksDB, and a Cassandra provider right now. But all these interfaces are also public, and it's not complicated. Like you have to implement a put, a get, and a scan function basically, and a delete. And it has a test suite that you can use if you want to use it in your own database that is not officially supported yet. It's not very complicated to write an implementation of these 2 interfaces, I would say. And it can be tested with the official test suite that is published as a separate artifact. But what I wanted to show is that so there is a ZIO Flow server sub project in ZIO Flow, which is right now not really published in any way. I was planning to pack it in a, I don't know, probably a Docker container or something like that. But right now you can just run it from the ZIO Flow repository by doing ZIO Flow server /run, and it will start up with the default configuration. It's also possible to set an environment variable and show an overridden configuration for it. Okay, I will show it's started. So now we have something that is running on this port on localhost, and it provides some extra features compared to what I just showed with the embedded version. One is that it provides, and we can go here, and it has a definition of the REST API. So it has a templates API, and the idea is that you can submit named Z flows, which can have input parameters as well. It stores them in some persistent backend, and then when you are submitting, the other API we are providing is the flows API, where you can submit a workflow to be executed. You don't have to send the ZFlow, serialized ZFlow all the time. You can just refer to it by the template ID. So that's one extra feature that we have. And other than that, you can query the result of the running flows. You can pause them, resume them, abort them, and so on. And it's also providing a lot of Prometheus metrics, but I think in the end it will be also configurable, like with any kind of metrics backends that ZIO metrics connector supports. Yeah, so this is now running, and let's try to use it with the test flows that we defined, like for example with this yeah, for example with this custom service execution thing. So one thing that is not ready yet is that we don't have a Scala REST API client, so we have to do it manually. And so this REST API provides this ZFlow template type that we have to submit to store a flow. So I will just do the ugliest thing now and copy paste it here and do it manually. So this is just a pair of a flow and an input schema, which defines what kind of data type you can pass it as an input, because this is serialized into a database, so these type parameters are not preserved at all. So we have to serialize a value of this to JSON. So that almost everything in ZIO Flow is based on ZIO schema. So here again, what we have to do is first define a ZIO schema. No, ZIO schema for this type, and we can just derive it. And once we have this, we can write just a helper for this demo that we want to have a flow of ZFlow. And let's say we assume that it always has a input, and we have a schema for that. And we would just want to print a string representation of this whole thing, just to help us calling the service by hand. So what we do is we take the JSON codec from ZIO schema and get a JSON encoder from a schema, which is schema, and we call encode JSON with a value of this type, where we can pass the flow is a flow, but we have to probably manually cast it to this any. And the input schema that we don't want to deal with flows which are not having any input right now. So what is wrong with this? Okay, yeah, so let's just, this flow schema is just a helper. It's not really important, but you can construct it from the schema of R. And this is this has to be converted to string. What else? Yeah, this is a not very friendly API. It's not how the final version you will call
Yeah.
the ZIO Flow service, of course.
Okay.
Yeah, so we can just say, let's print this to Flow 5. And it's, oh, schema. Oh, it's not the best example because it doesn't have an input, and I just thought that we don't care about those cases. Yeah, let's do it this way. Okay. Pushing the wrong buttons all the time. Yeah, so it printed something. This is the JSON representation of this flow. And I prepared some templates in Insomnia to call this API actually. So this is the copy-pasted JSON that we printed. And localhost 80, 90 templates, and let's give an ID. So if we call a put method on this endpoint and send this JSON, which the first part is the flow, which is quite long. And here in the end, it contains input schema, which just says that we need to provide a string. It's a quite complicated way to say it's a string, but it's that's what it is. So yeah, let's send this to our server, which I think is still, yeah, it's still running here. It's doing something. And it was a success. So another API can be used to get all the available templates, and now we can do that. We can see that it registered this. So yeah, it's a very advanced way to store JSONs in a database. And actually, this is how a ZFlow program looks like when it's serialized. So let's try to run it. And so running it is a post request to this flows endpoint. And there are a couple of ways to do it. You can send the ZFlow program embedded to the request, so you don't have to use this template feature at all. But now for this demo, we are using it. Template ID is flow 5, and the value is the let's write something else now. Just to avoid that you think that everything is hard coded somewhere. So yeah, so let's send this post request, and it just gave us back a flow ID. And if we go back to the terminal, it was logging a lot of things. And there is another endpoint where we provide this ID, and we can get the result or the status of this flow. So
oh no,
if we do that, it's an activity error, post request to our custom service failed, and its connection refused, and it has all this stack trace and everything. The reason is that I stopped the custom service before, so let's start it again. And so once a flow stopped, there is no way to retry that at the moment. That's probably something that could be added, but right now you have to submit it again. So as you submit it, you get a new flow ID. And if you query the new flow ID, and it worked. So cool. we called ZIO Flow server that called our custom ZIO HTTP server and returned this thing to us. And you can also query the results or the status of all the running flows. This is not returning the actual result values. It's just saying that we were executing 2 flows, and both of them are now done. But if those will be long-running flows, then you would see one is running. You can also pause them and resume them later. And if I would configure this ZIO Flow server properly, so the default configuration, I show it. The default configuration is using in-memory key value store and index store and JSON serialization format. But If you would configure it to use DynamoDB, for example, then if you stop the server and restart it, it will continue running your flows. There are also a lot of configuration possibilities to how to deal with errors on the HTTP request. So you can define retry policies for like a default one and per host one. It has circuit breaking, it has fixed and exponential retries, jittering, and every kind of features that you could imagine. So it's very, you can very configure it in much detail how to deal with errors got from these remote operations. The idea is that the workflow, on the workflow level, you don't have to care about this. This is the job of the executors. And yeah, and there is a configuration language for this, or I mean, ZIO configuration descriptors for all this, but you can also just provide them from code if you are using the embedded version. And one more thing that I didn't talk about is there are several things for scheduling. So yeah, similar to ZIO a little bit, but it's a more simple API. There is something called repeat, or there is another operator called schedule. And so if we do just the schedule, that will ask for a ZFlow schedule, and it means that it will not run it immediately, but it will run it once when the schedule is triggered. So, for example, here, if we just do this fixed and we say 5 seconds, then and let's do it like in a way that we also log the response. So if we do this and run, I'm starting to not see what I'm doing. Okay, here. And now if we run this live object, it will not call the service immediately, just after 5 seconds. Yeah, I think it did that. And of course, you can also do the other thing, which is repeat, and then it will call it every 2 seconds, let's say. And then it makes sense to combine this with other combinators on schedule. The simplest one is max count, which says that maximum 5 times. But there are also other combinators, like you can define another, like combine it with other schedule that triggers in other times with an or you can also, yes, there are some default ones that should make it easy to schedule every hour, minute, and second in every day, or every hour at a given minute and second, and so on. Yeah, so there are some default schedules, and we definitely can add more if something turns to be useful. So if we run this, it will do 1 request, 2 requests, 3. 5. Yeah, and it's finished. So this is how schedule works. There's also a special, I don't know if it's interesting or not, but there is a special syntax for doing recursion. Maybe I just go to the documentation first. So you would write a recursion. Yeah, so write a function of a ZFlow function that is recursive. like it checks if the input is 10, and if it's true, it's done. Or if it's not true, then it calls itself with a number that is n+1. So this is something that increases the n until it gets to 10 in a recursive way. And if we try to do this, it will not work. Actually, we can try. So let's try to run this. Okay, it's I don't see the problem yet. Oh, yeah, it has to use z nothing instead of nothing. That I don't want to talk about that. Yeah, Adam, you can talk about that if you want. Yeah. So this is what happens if you do this, and the reason is that even though the executor would be able to handle the recursion, you have to first serialize this to a JSON, and it's not possible to detect the recursive call when you are serializing this whole thing into a JSON. And because of that, there is a way to explicitly say you want to do a recursive function, and this is how you have to define this. So let's see what the difference is. You have to use this explicit constructor called recurse or recurse simple. There are two options. The difference is just one less type parameters, which sometimes makes it easier to infer things. But it has an initial value, which is 0, and this corresponds with this 0. Let's move it here. So initial is this. Then it has a function body, which gets a value which corresponds to n here. We can call it n. And it also gets a remote function, which is representing the recursion. And everything else is the same, instead that you are not calling a Scala function, but you are calling, I mean, not a named Scala function that you are defining, but you are calling this recursion placeholder that you got as a parameter. And if you do that, it will work. It's not working because it's a val and it's trying to just yeah, you cannot even define this, not even try to run it. Yeah, so it finishes with 10. So this recursion thing works like this. I don't know what else. That's basically what I wanted to show, I think. I don't know if there were questions or any other thing that.
Okay, now we actually have a couple questions. So we got one question from Tobias of, will results be cached, or is there the possibility to cache the result in case I call a flow template with the same input? I'm guessing not by default, because the flow is kind of factual. That might be like send a notification to someone, and if you send it twice, you might want to send a notification twice. But I would think you could build that with the var construct, if you could like check a var and set it afterwards.
Yeah, that's a good answer. So right now there is nothing built in for that, but I think you can write your own workflows with this. Yeah. So yeah, one thing about the persistent variables, they are currently not shared between flows, so you cannot use it for that. It's only shared between subflows. So if you are forking things, those can access the parent fiber or parent flows persistent variables, but you cannot share them between different runs of the flow. That's by design. Maybe it will turn out that it's not the best design, but right now it's by design. So there is no easy way to do this caching right now, I think. But I think one possibility is if you are not using the default server, but you are embedding it, then it's very straightforward because you can do the caching on the ZIO level. And another is that you can move the caching to some kind of external thing that you can call with an activity. So right now I see only these options, but
yeah. And it seems
yeah.
like that might be something where eventually we'd have, like, there's a ZIO.cached operator, there'd be a ZFlow.cached operator, and
Yeah,
it on the back end, whatever persistent store it's using, it uses to kind of store that and check that.
yeah, absolutely. So if this is a requirement that is important for you, please open an issue on GitHub, and then it will probably happen.
Yeah. And then there's another question by Caesar. Can the schedule be discarded by an external event, basically cancel a reminder when a task is done? So I think that would be kind of like interrupting one of these persistent fibers.
Yeah, so I would do that by running the scheduled thing on a fiber. And if you have I used fiber somewhere, you can interrupt the fiber from another one like this.
And is there a way to do that from the server? If you had, like, I guess, do you get back a kind of, can you ever get back like an ID of the, like, fiber that's representing it and then interrupt it while it's in process?
So you can have a persistent variable that you can wait for, like I did it here, to be set. And right now there is no way to externally set these variables, like for example through the REST API, but that is something that we have a ticket for, so that's planned. So yeah, in the final version or final release, or a very close next release, the REST API will provide a way to get a flow ID, get a, I don't know, persistent variable name, and just set its value from externally if needed. But right now it would work in the other ways, like you are calling external services, and when those external services respond with something, like you can poll something as an HTTP endpoint to get back whether you want to finish or not. And if you want to finish and you do this polling periodically, you can set your flows persistent variable to, I don't know, a Boolean variable to true, and then you can react to that in different other parts of the workflow by, for example, interrupting flows, or you don't really need a persistent variable for this, because you can just poll something in one fiber, and if you have a reference to the other fiber, then you can interrupt it immediately when you want to.
Mm-hmm.
Yeah, so yeah, it requires a little bit the opposite thinking. Like the workflow is the one that is controlling the workflow, and not you are controlling it from the outside with interfering with its internal state.
Is there a concept of being able to interrupt one of these fibers like there is with the ZIO fiber?
I don't understand exactly. So
so like if I had to reference this fiber, like on line 44, like,
yeah.
Can I do fiber.interrupt?
Oh yes, you can. It has an interrupt.
Because I was thinking the other thing you might do is maybe, like, at least with the server API, when you submit a flow, like, you get back a response that tells you here's the ID of the fiber that's executing the flow. And then you could have some ways of, like, oh, well, here's this fiber. If you wanted to, you could, like, interrupt it, or you could, like, check on it.
So you can always interrupt already in the REST through the REST API as well.
Okay.
You can interrupt the top level flow. This what I was talking about was the forked subflows.
I see, the subflows
that you are not accessing from the outside. So if you just do this that I did here, that run something and you get back a flow ID, I don't know what exactly it is, but something like interrupt and flow ID, or in the other way around. If you do that, then it will interrupt your flow.
Got it. So you've already got that.
Yeah, we get that.
Yeah, nice. Any other questions from folks? I think this has been super helpful. I mean, I think probably as folks can see, there's like a little bit of extra work that you kind of need to do to like work with this because of this idea that we want all these things to be values that you can serialize. Like if you're working, if you just have some normal function that's like doing some processing, even like on a collection, like if you have some method that's doing it, it's just a method. It's not something that's introspectable. And even if you have a ZIO, like if you have a ZIO that's kind of a flat map this, flat map this, flat map this, like there are a bunch of lambdas built in there that again make it something that's like not necessarily serializable because maybe it's like capturing over something else. And probably like if you've used Spark, you may have run into that. So there's like a lot of work that kind of goes into making sure everything that happens here is serializable. And a lot of that's on the contributor end of like what Daniel and the other folks who've been working on ZIO Flow have done, but a little bit is on the user end of you've got to do things sometimes a little bit differently. But the power you've got there is like, I think you saw at one point, like when we uploaded one of those flows to the server, like we actually just were able to see in like JSON a description of exactly what this flow was, which is kind of the power of that. And then that kind of enables everything that's going on here of we can restart this and we can perform all these different operations on this thing. So that's really cool. Oh, I think we maybe have one other question. So if you store a flow persistently and sometime later you modify your Scala code, will the flow start to fail?
So no, because the persisted state contains the full ZIO Flow program serialized, or at least the actual continuation of that. So even if you, let's say, you are running a workflow and the Scala code that defined it is so the flow definition itself changes. The running, I think, at least that's what I understand the question is, the running flows will not be updated to that. So it's always running with the flow version that was available when you submitted it.
And the flows are kind of self-contained.
Yes, exactly. And yeah, and the other question related to that is then what if you want to change it? Like it's a long-running flow, like it's the transfer days, and you found a bug, and you want to do something with something that you already submitted, and that is currently not something that we can do. So if you submitted it, then it's running with the original code until it's done. So it can be mitigated by some manual work, probably, like somehow enabling it to persist it to some kind of external persistence and then reload it from there, but there is no built-in support to do that right now. Maybe there will be something in the future. All
right, awesome. Well, thank you so much for joining us and sharing this with us. It's amazing work you've done here, and it's really cool. I think we can see there are some areas where like it's still like it's the RC1, so there's like more stuff that like needs to be done, and I think stuff that can be polished. But it's really impressive where it's gotten to, and I really hope some folks here will take some time to kick the tires on it, because I think it's kind of at a stage where it could really benefit from people who try it out, especially if you've got some type of like real use case where you could use this type of functionality, because that's what's going to help make it better.
Yes. Okay, so thanks for watching us.
Yeah, thank you so much. And yeah, thank you so much, everyone. Have a great weekend. Enjoy the rest of your day. Bye.
Thank you. Bye.